With uh, you or somebody else, if you can give us a background of what is Xart,
Sure.
or you pronounce it.
Definitely. So it's Xartup, basically. Xartup Fellowship is a program for early stage entrepreneurs. So we conduct cohort-based programs in which participants who are building a startup in their early stages, let's say, few of the folks are working professionals, few are students, few are full-time into their startups. But the only common theme between the audience is that they are building their startup at this point in time. So they come together, go through a program where they meet some mentors. We have some guest mentoring sessions like we are having right now. We have some demo days, and that's basically how the community is built. It's been 2 years for us as of now.
Okay.
Sure. So we can maybe begin with our conversation, Bafta.
Sure.
Definitely. So to give you a brief understanding of why we do these kind of sessions, it's basically to humanize entrepreneurship. We listen about stories which are heroic, right? Maybe Sachin Tendulkar, Lata Mangeshkar, whoever it is. And that becomes something where people can't relate to their story, their own story, basically. So here we try to go through your struggles, your experiences through which you have built the company. And that's what helps a lot of entrepreneurs. So we'll do that for a few minutes around your background, how you came up with the idea altogether, and then we'll go through your company, what you are going to build. And then towards the end, we can interact with the folks over here, take up their question, if that sounds good.
Sure. Sure. Sounds good, definitely.
Definitely. So to give a brief introduction about...
Okay.
Sure.
Sorry, go ahead.
No worries. So to give a brief overview about Bhakta is the founder of Chara Technologies. They are an enabler in the clean tech ecosystem, basically enabling EVs. That's what I have primarily gone through. But we would like to know more about Chara Technologies as well. But before that, Bhakta, what was your journey before building Chara Technologies? What was your background? How did you got started with entrepreneurship at the first place?
Okay. First of all, thanks for inviting me for this session. Much appreciated. I'll definitely share with you folks my journey and my experiences. I can give you a brief background about myself. I do have a presentation, but there is no need to go through the presentation. That's more of a company presentation. But we'll play it by the ear if you guys prefer that. So quick. Where do I start? I'll start from birth. I was born and brought up in Bangalore. Studied in a government school, St. Joseph's, UBCE. Then, like a lot of people in the 80s, I did go to, I probably do that. I went to US, studied there at Arizona State, got my master's, and then I worked for this large semiconductor company, Intel, for various reasons, mostly cultural and social and familial. I did move back permanently in 2006, and I worked for Intel for a couple of years, and then the entrepreneurship bug bit me. I was pretty old when I started my entrepreneurship journey. It's very weird, I think. compared to all of you guys here. I'm assuming all of you guys are younger than my kids. And then I suffered for a year, trying to figure out what to do. Then I started a company called Xartup. Some of you might have heard about it. It's a fintech company. Did reasonably well, and then it got sold to another large fintech company called Razorpay last year. Fairly good exit for everybody. It's there all in the internet. You guys can look it up. Then after that, I started Chara. Chara stands for motion in Sanskrit. Building rare earth free motors for EV and various other applications. That's my journey. Digging a little bit deeper, in my first part of the journey, and even now, the thing that bothers me a lot is that we have not built a product companies out of India, be it in whatever field, whether it's software, hardware, or mechanical. And we have been generally followers of technology.
कल तो सुबह ही आ जाइयो यार, आज मैं आता पूरा वो तक टाइम भी सही था, ये 3-4 घंटे लगातार बारिश ही हो गई और बारिश में अभी भी भीगता हुआ यार.
Somebody should mute, I think.
Please give me a second.
Or whoever is the admin can mute everybody. Yeah. Can you guys hear me now?
Yes.
Okay.
Yes.
So that was a prime reason for my journey on entrepreneurship, building a product company, building a technology. That's what we did in Xartup. And now, after that, I have a hardware background, and I have an embedded firmware background. And after exiting Xartup, I was looking at my next gig. And that's when I looked at this was in 2019, just before the COVID kicked in. And that is where we were looking at the electric vehicle technology, and primarily from a clean tech climate point of view. I truly believe that we, as the intelligent species on this planet, have cooked the planet pretty thoroughly. And if we don't do anything quickly, I think we'll all be in trouble. And one of the major trends that is happening is that we are moving away from hydrocarbons as a source of energy to electric, which is generally cleaner. I say generally because a lot of electricity is also produced by hydrocarbons today. But in the long run, electricity will be clean, which should help us in cleaning up the environment. But when we look at electric vehicles, there are two major components in the electric vehicle: the battery subsystem and the powertrain, the motor and the controller. Both are imported today. The batteries are imported, the battery management system is mostly imported, so is the motor and the controller. And that's the problem we wanted to solve. Build indigenous technology, because India is going to be a huge market, and we should be able to export it if we build a good indigenous technology. That is when we realized that there is this problem of rare earths. Yeah, I'll come to that. By the way, we are not in the battery business. I'm answering Naveen Garg's question, but that's a good question. So if you look at rare earths, there are the 17 minerals on the periodic table. If you guys have not heard about rare earths, please Google it. Look it up. It's critical for our future. It's used in motors. It's used in batteries. It's used in electronics, defense equipment. These are the names typically end with IUM, neodymium, dysprosium, samarium. They're used in electric motors. And their rare earths have a few problems. They are expensive. They are difficult to mine and earth, both economically and environmentally. They have some temperature issues. Last but not the least, the China has 90% control over the supply chain, and that is where we thought we should solve. We should try to solve that problem. And what we do at Chara is very simple. We build rare earth-free motors for electric vehicles and other applications. I think I'll take a pause here. If you have any questions, I'm happy to answer. We can make this a dialogue, or I can go through the presentation just to give a deeper look at what we are building.
Sure, that would be helpful, Chara.
Okay.
So that we can get a technical overview about your company, your business, and then questions would be better.
For my curiosity, what is the background of the people here? What kind of companies you are trying to build? Hardware, software, services, or is it a fair question to ask?
Yeah, definitely. You can put it in the chat box, the industry that you belong to, folks. It will be helpful.
It will be helpful for, I'm curious what younger people are thinking about. Yeah. So let me open my presentation. No. Okay, great.
It's very diverse, starting from fintech to services, SaaS, waste management, sustainability as well. Deepa is there from Xartup.
Oh, okay. Oh my God, there's a lot of messages. Always curious. Carbon credit. We are also curious about that. Camping, MVP, renewable energy. Fintech. That was my previous company. But I am a hardware guy. I'm not a fintech guy. Healthcare, AI tech. Very cool. Yeah, I'll try to answer that question, Sumant. EVs are not completely green. That's the most often heard argument, which is true now. But in the long term, I think they will become green. And the question about decent waste ecosystem for EV batteries and parts, that is a huge concern. If we don't do it well, I think there'll be massive wastage and poisoning the environment. There are people all over the world, universities, governments, and even well-funded companies looking at how do we recycle the batteries. Whenever we, especially in automobile industry, we have to think from start to end. Where are all the parts coming from? Where will the parts go at the end of life? That is not still very clear with electric vehicles, especially with batteries. I think the remaining part of the vehicle is fully recyclable, plastics and metal and other parts. The batteries is a problem. I think that is a fantastic problem to solve. It's a fairly deep tech problem also, but that is something that one should do. Let me share my screen.
Sir, sorry to interrupt, but you said about some deep problem. Please highlight on that as well, maybe through your presentation or if you want to highlight now.
No, I was telling that recycling of batteries is a deep tech problem. Involves a lot of deep technology, which people haven't figured out yet. the huge challenge, a huge opportunity. So, so that also raises a question. We consider ourselves as a deep tech company, and I don't know what is the exact definition of a deep tech company. It is kind of loosely used, but we go by the definition as follows: three principal distinguishing features of a company which can be considered deep tech. Number one, the technology that we are going to develop should not have been deployed anywhere else in the world. So this will be the first time that will be deployed not only in India, anywhere else in the world. That is number one distinguishing feature of deep tech. Number two is typically from start to first shipping for revenue is about a 5-year journey. That means it's a really hard problem, both engineering wise and science wise, that needs to be solved. The third thing is, people don't like when I say this, deep tech companies are generally started by more experienced people, quote unquote, older people. We need a lot of experience to build deep tech companies. I mean, by the way, we satisfy all these three. So you can think I made up this definition, but I did not make up this definition. Actually, one of the IIMs when I visited, they were telling, a lot of people claim they're deep tech, and that's all. Yeah, that's our definition. We go by the definition. Okay, I'll start. You guys can see my screen, right? Okay, great. So we named our company Chara. Chara stands for motion in Sanskrit. Like Chara, Charaka, Chara Jagannatha. The basic premise behind this naming is that motion is fundamental for humans. We always need to go from place A to place B for work, for entertainment, and for love. And we need to run our fans. We need to run our home appliances. We need to run our machines in the industry and the office. Motion is fundamental for us. But all the energy for this motion is coming from hydrocarbons today. And we now know the negative externalities of that hydrocarbon addiction. That is why we are shifting into electric future. Electric, because electricity is the only known source of clean energy, which is easy to produce, easy to transmit, fairly easy to store, and at the point of consumption, it is completely pollution free. So when the motor runs, when you feed electricity to it, it's completely pollution free. And that's why, and it's fairly well established. Technologies are at least 200 years old. So that is why we are shifting into electric future to save ourselves. So once we go into the electric future, the motors become important, the prime movers. They will become the prime movers. Motors will be everywhere, including our vehicles. And there are broadly two classes of motors. We have something called induction motor, our ceiling fans, our home appliances, various motors in the industry. They're all induction motors. They are about 60 to 70% efficient. That means they are neither sustainable economically or environmentally. If you remember, we moved from incandescent lamps to LED lamps. The same transition will happen to save a lot of energy on this planet. There are efficient motors today. They are usually called BLDC or PMSM motors. They have this NdFeB magnets in them. Neodymium ferrous boron magnets or samarium cobalt magnets. And neodymium, samarium are the rare earths, which I mentioned before. And they have their own problems. Rare earths, expensive, difficult to mine. And China has 90% control over the supply chain. Which leads to supply bottlenecks, cost variations, geopolitical outcomes, and bunch of those things. So what we are doing at Chara is very simple. We are building rare earth-free motors, which are as efficient as the existing motors, and which are mostly aligned to the industrialization 4.0 initiative. They're more intelligent motors. We're initially targeting electric mobility. We look at all the other motors, like our appliances, our fans, our industry motors in the future. In the future. So that is what we do at Chara. Rare earth-free motors, which are efficient and intelligent. Excuse me. Get some water. So to realize this goal of building rare earth-free motors, we are using the technology of reluctance. There is a class of motors for reluctance motors. Incidentally, this technology is 200 years old. You can Google it. The original paper goes back to 1838. And this was the first motor invented by man when man invented electricity and magnetism about in the early 1800s. But these motors never saw the light of the day because they had a bunch of issues. They're highly nonlinear systems, very difficult to control. They have torque ripple, they have noise problems, a bunch of other problems. So we at Chara have done a lot of fundamental research on motor design, hardware design, and algorithms to solve all these problems. So we at Chara build the motors, the hardware, and the software that controls the motor and supply it as one product to our customers. And again, to reiterate, we are completely rare earth magnet free, which makes our motors cheaper, which is very attractive in India. India is a very cost-sensitive market. We are as efficient as the existing motors, and again, no supply chain dependency. And to answer one of your questions that is similar to batteries, at the end of the life of the motor, whatever it is, 10, 15 years, they're completely recyclable. Our motors are made of aluminum, steel, and copper, nothing else. So that they should be completely recyclable, which is important in the long run. So as I said, the standard reluctance motors don't work, difficult to control, torque ripple, noise, power density, and all those things. So what we have done is we have done a lot of fundamental research, R&D, deep tech work, older guys. And so we have now built motors that are as power dense as the existing motors. They're also quiet and smooth. We have built motors for HVAC, that NEMA 48 motor is an HVAC motor. We also built a two-wheeler motor. We have built actually more, we'll come to that. One of the, like the current trend, right? Everything is software controlled. In our motor, the software becomes more critical. We conquer the non-linearity and the torque ripple and the noise through very intelligent and fast executing algorithms. So our motors are sometimes called software controlled motors. They're more, software is a more critical portion of our motor. So this gives us an opportunity to manage our motor as a software entity. So what we are doing now is we create a detailed digital model of a physics model of the motor, and this is usually called digital twin. So we create a digital twin of the motor, physical motor, virtually on the cloud, constantly update the parameters of the motor. That way we know what is the exact state of the motor. So at a minimum, we get fantastic diagnostics. If something goes wrong, we know what exactly went wrong. We can also do predictive maintenance. We look at the motor and say, dude, this is something is wrong with this motor, go and fix it. But in the long run, what we want to do is we want to update the parameters and the algorithms in real time or near real time to make the motor run more efficiently, or as we call it, more optimally. So these are our customers today. So we have customers in HVAC. Amber is a HVAC company. Bounce is a mobility company from Bangalore. At least people from Bangalore know about Bounce, I think. We are building a very large 22 kilowatt motor, high voltage and liquid cooled motor for the Tata group of companies. There are a couple more which we don't have permission to publicize here. We also built a motor for a three-wheeler based out of a grant from the Indian Institute of Science. Basically, the government of India also believes that rare earth problem is a nationally strategic problem that needs to be solved. Again, for people of my era, the last 75 years, if you look at it, since we got independence, we have been dependent for our energy on Gulf countries, right? Primarily Gulf. I know nowadays we are getting oil from Russia, but primarily Gulf. By the way, the rest of the world. And that has led to a lot of, we spend $500 billion every year to buy our petrol, which is a huge outflow of foreign exchange for us. luckily, we are doing a lot of other things, and we are still foreign exchange positive, at least in the last 20 years. But there's a huge drain on the exchequer here. As we transition from hydrocarbons to electrons, if we don't do anything, we'll be dependent on China for the next 50 years or the 75 years. And that is what we need to avoid, which is a hard problem, which is a deep tech problem. That's what we're trying to solve. But the advantage is, if we solve this problem, India is not the only market. The rest of the world is also is a huge potential market. And that's what is driving our. And a little bit more into technology, we are building scalable tech platforms. So basically, we build why this page is important is there is nothing like a standard motor in this world. Every motor is a little different, like every petrol engine is a little different, right? So what we are doing is we have built like 4 or 5 standard platforms. And so when customers come and ask, they fall somewhere in between, and we can quickly change a little bit of the size or some other parameters and supply a motor. So scalable tech platforms is a key thing that we have done. And again, scalable tech solutions, we build one motor. So we are building this 22 kilowatt motor for Tata, and we can make it a little bit bigger and make it a motor for a car, mid-size car, like a 2-ton car, or make it even bigger and make it run a small bus, or make it smaller and and we can use it in a 2-wheeler. So scalable solutions is one of our key features. Again, quick look at the competitive landscape. The x-axis is the cost. The y-axis is the efficiency. If you look at the induction motors, which I mentioned, they are cheaper, but they're not efficient. We need always efficient motors. If you look at the existing motors, PM motors, permanent magnet motors, which have reliance in them, they are efficient, but they're not cost effective. So we fall into the top right quadrant, where we are as cost effective as the induction motors, but as efficient as the permanent magnet motors. And then, so quick introduction about the founder. So my name is Bhakta Keshwachar. You heard my story. Ravi is our chief motor designer. We both studied in the same college, slightly different times, very senior guy. He is one of the few people in this country who can build, design, build, and deploy motors, and has done it throughout his life. Maha is our algorithms and power electronics guru. Why the three of us are kind of, it took a long time for 3 of us to come together. This is critical because building a motor and its controller is a multidisciplinary activity. So we need people who understand electromagnetics. We need people who understand mechanical. After all, motor is a mechanical thing. We need people who understand thermals. We have to remove the heat from the motor as quickly as possible, like any engine. Then we need power electronics, and then we need algorithms. So the founders kind of closely reflect this wide range of disciplines that needs for a product like us to be built. And similarly, we have built a multidisciplinary engineering team with these leads to reflect that reality. And this is one of the hardest things about building a motor and a controller, which should give us some edge over competition. Quick look at the timeline. Again, a little bit of a storytelling. 2019, just before COVID, I exited from EasyTap. Then I started looking at other things. Q2 and Q3 was more about exploratory work. Initially, incidentally, we thought of building a platform which has the motor and the battery fully made in India, so that I can go sell it to OEMs so that they can build their vehicles around it. Then we realized that battery is a $1 billion problem. It needs amazing amounts of investment, 10,000 crores, 20,000 crores. And maybe we'll go there someday, but other people are looking at it. But we have solved the problem of the motor. So completely designed in India, starting from first principles, uses materials that are locally available, which is locally available. That is true for any country: aluminum, steel, and copper. Then we narrowed down to that problem definition, we incorporated the company in the last quarter of 2019, and we started building the protos. The proto was getting into shape, and I have to admit here, investor feedback was very muted. He's like, "What are you talking? Who cares about motors? Who cares about deep tech? Who cares about hardware? All these problems are there." And I knew the investors, given my background, their investors were friends who come to my home, and even they were like telling, "Dude, this won't fly." But we stuck to it because we knew the rare earth was a huge problem. And I'll come to that in a moment, how things changed, which is very important in the journey of a startup always. The externalities, unfortunately, define your success. It's not only you. Then, of course, Q2 or the end of Q1, lockdown happened, pandemic came, we were all stuck like deers in headlights. But we did a lot more simulation and design. Incidentally, this is when we got the award from Indian Institute of Science, all over Zoom calls. Then we started. Then we went back to office. There were only 3 of us, and I think we just had 2 helpers. And we started running the motor. We finally figured out how to do it. Finally, CIIE, based out of IIM Ahmedabad, which primarily distributes government money, they committed for an investment. And this was all over Zoom calls. And then Kalari came in and also committed the investment. Apart from all other things, this was very weird for me because, in my previous company and at Intel, we used to jump onto a plane for no good reason. Somebody wanted us to come, we go there and say hi and come back. Now, we signed up customers, we raised $1 million all on Zoom calls. I know a lot of people did that in the world, but it was very disturbing for me. Disturbing in a very good way, without seeing people gave us a lot of money. But that was an interesting time. And then we closed this seed funding of $1 million. And we also did our first customer sign up, again, all on Zoom calls. Then we signed up our second customer bounce. But then we landed into an engineering problem. So whatever we started on building the switched reluctance motors, finally we realized why it has not been deployed. Because even though we built and tested, we did a lot of design, the results were not promising. This was a big setback and extremely valuable learnings. And maybe someday we'll go back and crack this switched reluctance motor problem. But then we continue to look at it. Then we signed up Tata for their larger motor. And we continue to struggle with, now I am at Q1 of 22. We continue to struggle with our switched reluctance motor problem of noise and vibration. That is when we shifted gears and we built what is usually called synchronous reluctance motor with ferrite magnetic system. And that one delivered on all the promises, which is efficiency, no rare earths, cheaper, no dependency on foreign sources for critical materials. And we built the motor and we put it on the scooter and did a small video on which I think 500,000 people saw it. And then after that, of course, the bigger 35 kilowatt motor started running in the lab, which was very cool because liquid cooled motor, liquid cooled electronics. As far as we know, nobody in this country has designed and built a motor at this voltage and this power. And we did a road test of the Tata ES vehicle. And then 3 months ago, we closed our pre-series A round of $4.75 million. We finally closed it at 5. And there were a few other people who came at the last moment. And then 20. Now we are, we are hiring madly. So if anybody knows people in any of these areas, and of course, we are also hiring marketing and sales product. Please drop us a line. But one big change happened. We are now thinking of manufacturing. We'll actually manufacture. Initially, it was IP and design licensing, and somebody else builds the motor and we get a royalty. Now we are thinking of manufacturing, and we are working on even larger motors, like a 125 kilowatt motor. Then quick look at the technology roadmap, which is important for any tech company. 21 was building the SRM and the SRM stack motors. Last year was building this motor management platform, which we believe will be a big differentiator for us in the long run. And in this year, we're going to build the design platform, which can design our motors better. So today, the design of the motors is more based on the experience of Ravi, experience of Rajat, Maha. They know where to start, where to end, and we think that's the most efficient motor. But we believe that if we take all the learnings of our team and put it in a rule-based engine with additional artificial intelligence type of technologies, we should be able to design motors faster and get better designs. It's just because a computer can look at a larger design space problem than humans. And this will be a big deal for us in the long run. And after that, we'll start looking at custom silicon to help our products run better, cheaper, and more efficiently. And we'll also start looking at other technologies. Reluctance motors is not the only technology that are rare earth free. There is something called rotating transformers, electrostatic. We'll start looking. We are a tech company, so we'll continue to look at new technologies. In terms of business milestones, 21 was proof of technology and the HVAC and the EV motor development. And 22 was building the bigger motors. This year is about pilot production and deployments. Our main goal in the company now is to deploy these motors in the next 12 to 18 months. This is a nice story to tell now. People like about made in India, rare earths and all that, but we can't tell this story forever. We have to deploy our motors, and that is the main goal of the company in the next 12 to 18 months. So hopefully next time I get a chance to speak like this, I should be able to say we did all of this, and by the way, it is deployed in product X and product Y, which you can actually go and buy in the market. And then of course, next year is about mass production and expanding our portfolio and generally ramping up in a fashion. That's what I wanted to share with you guys. We can use the remaining time for Q&A or whatever you wish for.
So it was an amazing story coming out of a very humble background. So it was nice to hear that the stage and milestones that you have achieved. So we have few questions already there in the chat box.
Okay.
Can look into that. I'll summarize few of the questions. So Naveen is asking, so I think you mentioned this aspect that China is
yes.
only country of this element. So in future, is it something which is going to be a problem? And that's what I guess you are solving. So maybe.
Yeah, that's what we're trying to solve, Naveen. I don't think China will stop, even though they also need money to sell. It is what we are also seeing is it is not just China is the problem. China is the problem now. The process of mining and extraction is environmentally very hazardous. By the way, these are called rare earths not because they are rare. Gold and diamonds are rare. These are called rare earths because the amount of neodymium which you can find in the ore is very small. It's like 0.3%. So you have to process a lot of ore to get that few grams of neodymium. And that is environmentally very hazardous. It's very hard to predict what will happen like 5 years into the future. Will China become a problem, or China will say that, hey, it's to the benefit of everybody and we will make it better. But I think the fundamental problem is not China. The fundamental problem is the process of mining and extraction is not scalable. And I say this a little bit more confidently today because I don't know if anybody follows Tesla closely. They had their investors day, not Thursday, not yesterday, but 1 week before, on Friday morning here, India time. And they, this is their dog and pony show, Smoke and Mirrors, where they announce everything. In there, they also said that the future motors of Tesla will be rare earth free. So it is not only us, everybody in the world is thinking about getting away from rare earths. It could be political, it could be China, and it could be that the mining is not so environmentally friendly.
Thanks. So another question is there from Deepa, quite relevant to the automobile space.
Deepa, is it?
Yeah.
Oh, end of life. Yes. End of life is a huge problem. So, and that is, we are solving a small problem. The rare earth magnets are not recyclable. So our motors are completely recyclable. As I said, aluminum, steel, and copper, the most recycled metals on this planet. People say that when you buy a kg of copper, 60% of that copper is actually recycled. Same with iron and aluminum. The end of life. Yeah. So carbon offsets for setting up solar powered infrastructure. Yeah, that is happening. I am not sure if we set up charging infrastructure for EVs, will that also give us carbon credits? I'm not sure. I'm not an expert on carbon credits. Maybe they should, but we are also looking at the carbon credit ecosystem. We are also learning because we also want to go out and say that our motors have lower carbon footprint because we don't use rare earths. Our charging infrastructure also might turn into carbon credits.
May I ask the question?
Yeah, please. Yes.
Okay, so I just recently heard from a person who had gone to a hill station in Sikkim, Darjeeling area, and there was a Royal Enfield there, and they were saying that EVs are not a good option in the hill stations because the batteries don't start in the cold atmosphere, and the battery's efficiency will also be very less as compared to petrol's efficiency. So, and I don't know if any company or anybody in the automobile sector is looking for solutions in that space, because everything else is very eco-friendly over there in those villages, and a lot of tourists go there using bikes, and bikes are the only option to for transportation there. That was one question I wanted to check with you, sir. And another one main important question I wanted to check with you was this: a journalist was telling me this 2 years ago during the pandemic, that every automobile brand is trying to customize its parts like batteries and engine in such a way that when you come for recycling, like a brand like Maruti cannot get a recycled battery from a brand like Ford. So there is some kind of monopoly going on which is making recycling very tough. So I don't know, I mean, I should ask this in a public forum, but just wanted to get a take if it is allowable. Yeah.
It's a very valid question. There's nothing wrong in asking that question. Everybody should ask the same question. So I'll try to answer your first question. You're absolutely right. The current battery technology is like humans. The temperature ideally should be about 20 degrees, 25 degrees Celsius for it to work more efficiently. it can neither go high temperature, neither can it go low temperature. If it goes into high temperature, it will catch fire. So that is why most of the good battery packs are liquid cooled. If you go to low temperatures, their efficiency will drop, which is not a big problem because once you, by the way, which is true of electric, even petrol vehicles, they are also not very good at very cold temperature. I'm talking about cold temperatures like minus 20 degrees Celsius and all. At 0 degrees, I don't think anybody has a problem. If you go to like minus 20 degrees Celsius, Celsius, what will happen is initially it will be inefficient, but as it starts producing electricity, it produces heat, right? They will use that waste heat to heat up the battery and the motor, and then maintain it at a correct temperature. So I don't think that is that much of a problem. There will be some initial problems. Engineering will solve it. Now about the recycling, you're absolutely right. Every automobile company uses its own proprietary battery cells, battery technology. So there is no way we can use batteries from one manufacturer to the other. And there is no effort to standardize the batteries. It is completely transparent to you. They are sitting somewhere in the inside the vehicle. It's a black box. You don't know what is inside. You use it till it dies, and hopefully somebody recycles it in a good fashion. I don't see any effort either at an ecosystem level or even at a business level for the batteries to interoperate. Unfortunately, that will not be the case. We just use the batteries and run it till its end of life. The only hope is that, which is what I mentioned at the beginning of the call, is that we figure out how to recycle